Hello, welcome to ABA 502. Today we are going to cover more measurement of behavior. This is a second part. And what I hope to do in this second part is review some of the critical content from last week. Obviously, we're not going to get into great detail because there was quite a bit of detail last week, but there are some things I want to highlight and perhaps clarify. Then we will have a brief overview of the Fahmy and Hanley article and the Fisk and Demolino article. Actually, I'm going to present the Fisk and Demolino article first, followed by the Fahmy and Greg Hanley article. So there was a lot of content we covered last week, everything from selection of target behaviors to defining target behaviors or operationally defining target behaviors. And then we got into measurement, which is sort of a whole area unto itself. So there was a lot of content. I realized that. That's why I wanted to really dedicate 2 weeks to that. So in addition to this lecture, I hope that you do go back and review the lecture from last week, or at least read through the APA handbook again, just to get a good grasp, particularly on all of the measurement procedures. I noticed in the quiz some folks struggled with measurement procedures. So we discussed the unit of analysis in behavior analysis, whether it's experimental analysis of behavior or applied behavior analysis, is the response class, right? Or we might just refer to a response, which would be a single instance from a response class. So that's sort of the formal term, and it is a collection of individual responses that have a common source of influence on the environment. And there are some examples here on this slide. So often what you'll see, particularly when you're reviewing applied behavior analytic work, whether it's clinical work or research, is that we are working with response classes, right? Maybe aggression as a response class or self-injurious behavior. Obviously, each of those response classes consists of a variety of responses. So, for example, aggression might include hitting and kicking. Self-injury may include biting, scratching, head banging. And not only is it important to kind of capture all of those features for each individual client we're working with, but we need to be able to define each of those particular behaviors as well. So when we're selecting a target behavior for a client, we're working really primarily in two areas. Why they're addressing behavioral deficits, so therefore we are selecting skills to work on. And we'll talk more about how to do that in other classes, ABA 511. Maybe we'll talk a little bit about it in 510. But essentially, when we are addressing behavioral deficits, we conduct assessments to determine current skill levels. Baseline data collection could be an assessment. So for example, if a teacher came to me and said, I have a student who's struggling with identifying their colors or letters, anything of that nature, I would take a look at the curriculum that's being used. So for example, I might ask a teacher, can you provide me some worksheets of the work that with which a student's having trouble? And I would see what's actually being done. So let's just say it's preschool level, pre-academic skills with discriminating letters and or colors. Then I could provide those worksheets and see what the student can and can't do, or provide instructional trials, and then determine baseline levels. And wherever there are deficits, those deficits would be my target, right? So I want to increase the student's ability to independently select the letter A in the presence of AB. So that's one area. The other area, which I think we probably talk about quite a bit because most of you are in ABA 510, is the area of behavioral excesses. So these are behaviors that need to be decreased. So challenging behaviors, self-injury, aggression, property destruction, and so forth. So those are the two broad areas, and we are selecting target behaviors individually for the client we are working with. Now, if we're involved in research, we might be selecting target behaviors that are relevant to the research question. Now, one thing I wanted to clarify from last week is that when we're selecting target behaviors, we need to be careful not to select too many. Often when we're called in to consult, the individual or the client may be presenting with a variety of challenges. They're exhibiting challenging behavior. They have a variety of skill deficits. So therefore, we need to prioritize which behaviors we're going to target initially and then which behaviors we will target later, right? Because we can't do everything at once. Now, that said, it isn't unusual that we may have several targets we're working on. So we may be working on decreasing aggressive behavior, increasing communication, and then maybe addressing something like an activity of daily living, like toileting. However, even if we're simultaneously addressing all of those, one would take priority, and that would be any behavior that causes a risk to self or others. So some general guidelines we might want to use in prioritizing would be that those behaviors that do cause risk are addressed first, right? Let's take care of those so then the individual may be more successful in learning activities, right? So if the individual's engaging in aggressive behavior and you're trying to also teach them toileting skills, that's going to be pretty challenging. However, if we address aggression first, then maybe we could easily teach toileting skills. So we need to consider that. So again, these are general guidelines, and I would say address behaviors that present a risk first, address behaviors that interfere with learning second. Now, of course, behaviors that cause risk do also interfere with learning, but I guess what I'm getting at there would be maybe pre-academic skills like attending behavior, or being on task, or being able to sit in your chair, or even disruptive behavior, right? So we need to make sure that we can address those before the child is able to contact whatever curriculum you're trying to present to them. Then we would get into other things, again, activities of daily living, pre-academic or academic skills, vocational skills if you're talking about adults. So these are not this prioritize or list of prioritization is not set in stone, but I would say definitely you would address behaviors that cause risk first. Then, of course, once we've selected and prioritized target behaviors, we need to operationally define them, and we do so by describing them either as a functional response class or providing the topographical description. So I had you do an exercise related to that, and we'll kind of talk about some of that later. The other thing that was presented last week in part 1 is selecting and setting up your observations. So we need to figure out, how are these observation periods defined? That is, when we go in to observe and collect data on the target behavior, are we going to do so in a continuous format across all waking hours, or a continuous format according to sessions or brief periods or samples? So these are simply things we want to talk about or consider. And what was discussed last week is the goal of an observation is to really allow you to collect data to determine or depict the true state of the behavior as it's occurring, right? So we'll be able to determine baseline levels of the target behavior. And then when we move to treatment, we'll be able to determine how those levels have changed relative to baseline. So we're selecting observation periods such that it reflects the true nature of the target behavior. So we want to make sure that we're observing when the target behavior was described to be occurring. And again, as I mentioned, you want to consider, I have an hour consultation period. Am I going to just observe that entire hour and report or summarize the data that I observed within the hour? Or am I going to divide that hour up into sessions, 10-minute sessions, right? So I could have, for sake of simplicity, we'll just say 4 10-minute sessions, and allows me to do some observations within the 10 minutes, take some breaks, maybe look at the data, do a variety of other things within my 1 hour consultation period. So that's something to consider. Are we going to carve out our observation into sessions? And if so, how long are those sessions going to be? I would say a good standard one that I use often is 10 minutes or perhaps 5 minutes. If I need to observe longer, I could do that. And later we'll talk about why we might want to do that, but to sort of give you an idea of why we might want to observe longer is if behavior is at a low rate, right? So let's just say that a parent describes a child as being self-injurious, but it's at such a low rate that it occurs maybe once every hour. So if I observe for 10 minutes or even 3 10-minute periods, I may not be likely to see the target behavior. So therefore, a longer observation period is probably better. The other thing to consider with observations that I don't think we expanded on last week is this notion of conducting a natural observation versus an analog. And for those of you who are in ABA 510, we've already discussed sort of this idea. Do we do the observations in the natural environment where the problem behavior is occurring, or do we contrive an environment, that is, set up an environment that simulates a natural environment? Now, there's an advantage to doing both, and at some point throughout our sort of behavior analytic process, we probably do both. So for example, if I'm working on a clinical case, I may have a couple different types of observations going on. Obviously, I need to treat the individual in the context in which they are living and exhibiting the problem. So if they're exhibiting problems in school, ultimately that is my target, that I need to address those problems in the school. However, doing assessments and evaluating if an intervention is effective initially can be challenging in the natural environment because there are a lot of confounding variables. So I may elect to not only collect data there, but also run these analog conditions where I'm simulating what's happening in the natural environment, but in a more controlled way. So what this does is it may allow me to analyze the behavior more quickly because there's not a lot of confounds. It allows me to establish control much more quickly because there's not a lot of interference. So if I have an intervention, me as a therapist can establish control over the behavior very quickly. However, then the goal is I need to go back, take the treatment out of this analog condition and make sure it's working in a natural setting. So there are options. That's all you really need to know at this point, that we can do everything in a natural environment, but we may experience some challenges, or we do everything in an analog environment, but then we have to generalize everything back to the natural environment eventually. Okay, so hopefully that makes sense. And again, I think those who are in 510 probably have a better idea because we talked about FAs in a natural setting versus analog conditions. The other potential for observation, particularly in academic settings or when you're teaching skills, would simply be trial by trial data collection. So we are presenting learning trials. Maybe there are 5 of them, maybe there are 10 of them, maybe there are 20 of them. Or maybe they're not particularly defined, but we intersperse them throughout the day, right? So therefore, our observation is sort of initiated when we initiate a trial. So I present, for example, an instruction, and I wait for the individual to comply to the instruction, and there is a trial, right? I presented the SD, trial began, I waited for a response, and then I measured whether the response occurred or not. So a variety of ways we could think about setting up our observations. Now, again, the important point is that they have to represent the natural state of the target behavior. Also, we want to be able to reflect when we intervene that there is a change in the target behavior. Another consideration about observations is the difference or differences that could occur in your observation duration from baseline to treatment as an artifact of the treatment you're using. So bear with me through this example because it can be challenging to understand. So for example, if you're using frequency or rate of behavior, so recall that would be the count of behavior divided by the time of the observation or the session. So it's the responses is converted to a rate or frequency. We have to give consideration to how often the behavior occurred during the observation, given the amount of time it was possible for the behavior to occur during the observation, or possible for the person to respond versus not respond. So consider this example. During our initial baseline observations, we observed a behavior, let's just say it was self-injury, hand-to-head hitting, during a 10-minute period. And we did multiple observations and we generated some baseline data. Let's just say we had 3 data points. So we ran 3 10-minute sessions. Within these 10 minutes, SIB could have occurred at any time. So let's just say I've done a functional analysis and I decided to use a treatment or an intervention known as response blocking. So now when the individual attempts to engage in SIB, I'm going to block those responses for a certain period of time. So now let's consider that we're going to evaluate that intervention. So we're running sessions again, and we're starting with 10-minute sessions. However, if the individual attempts to engage in SIB, I response block. Now let's just say I response block for 2 minutes. That is 2 minutes during which the individual has no opportunity to engage in SIB, right? Then let's just say a little bit later, I response block for 1 minute. That's 1 minute in which the individual cannot engage in SIB because I'm preventing them from doing so. So suddenly, if I only used a 10-minute session, it's not an equal comparison to baseline because I've reduced the amount of time that the individual can engage in SIB. So technically, if this observation, I know it says 13 minutes, but if it happened to be 10 minutes, but for 3 of those minutes I was blocking, there was only 8 minutes in which the individual could have responded. So that's not equal to baseline. So one thing that we certainly do it in research, we should do it in practice, but I suspect some folks don't, is correct for those periods that the individual cannot engage in responding. So in this case, what I did was when I blocked for 2 minutes here and I blocked for 1 minute here, I was sure to add additional time to my observation, right? So now this 10-minute session became 13 minutes because I had to correct for the time in which the individual could not respond. So again, what we're trying to achieve here is sort of that each observation is equal duration across all phases or conditions, in this case, baseline to treatment. Okay, the other thing we talked about last week is indirect measures versus direct measures, and we know that an indirect measure or an outcome measure, or what's referred to as a permanent product, is the result of a behavior. And these have their limitations. However, if we're unable to observe, this is one method with which we could use to capture how much behavior is occurring, or at least estimate how much behavior is occurring. Or at a minimum, we know whether behavior occurred or not. Maybe we don't know how much. So, for example, an injury left from SIB. I think I mentioned last week that I worked on a study where uh, there was an individual who engaged in covert skin picking. That is, they only engaged in the behavior when they were not being observed. So we set up some covert uh, data collection procedures where she wasn't aware she was being observed, but we also measured the severity of the injury, the size of the wounds being produced by the SIB. So therefore, we were able to sort of verify that the outcome measure of SIB was actually sensitive to how much SIB was occurring. But more simply, we may use an outcome measure to maybe assess completion of homework, right? As long as the worksheet's completed, we could be reasonably confident that something happened, right? That the individual completed the worksheet, or at least perhaps had somebody do it for them. Direct measures are more preferred. Here we're actually measuring the behavior as it's occurring. And within that context, we have an option to measure continuously, or continuous recording, that is, every instance of behavior during our observation period, right? So this doesn't mean every observation all day and all night, although we can do that. It simply means that within our observation period, we are going to count every instance of behavior. And that contrasts with discontinuous sampling, where during our observation period, we're only going to record a subset of behavior. To do that, we need to divide our session time into equal intervals, meaning they all need to be the same, right? So I always give the example of a 10-minute observation divided into 1-minute intervals, 10 1-minute intervals. Then during that observation, we're going to record occurrence of behaviors during the intervals and convert that into a percentage of intervals during which target behavior occurs. So here are all of the measurement procedures that we have available to us. And I guess I'll go through each of them and try to give some examples. Count. We're going to measure each instance of behavior. So some things to think about there is a count the most sensitive measure to reflect the true state of behavior? So something like self-injurious behavior in the form of hand-to-head hitting or head banging can probably easily be counted. Simply, we observe and count 1, 2, 3, 4. Duration is a time from behavior onset to the end of the behavior, and the amount of time in which the behavior occurs. So we often report this as either a total duration or a percentage of the session in which a behavior occurred. So for example, out of seat behavior. When we're observing, and the individual starts out of seat behavior, we start a timer, and when they get back in their seat, we stop the timer. Now, other behaviors such as stereotypy. So for example, rapid hand flapping, right? The individual flaps his or her hands, perhaps in front of her eyes. And we could count that maybe if you're wanted to take that on. So we might be able to count each hand flap, 1, 2, 3, 4, but that's not realistic and it's quite challenging and we're probably going to make a lot of errors. So it's better to count that as a duration or measure it as a duration because it doesn't, it occurs with such high frequency, it's too difficult to record each instance. And duration is just as sensitive. Often when we are taking account of behavior, we will convert it to a frequency. Again, some folks refer to this as a rate. Simply the count of behaviors divided by your session time or observation time. Latency is the duration of time between stimulus onset and the occurrence of a behavior. So for example, I might provide an instruction and the time between when I gave that instruction to when the person actually began to comply with the instruction is a latency. And we could use latency measures in a variety of ways. I think the example I just provided might be one way. But again, it's just simply a measure we have available to us. Inner response time is the amount of time between two responses. And we could calculate an average inner response time when we sort of look at the time between multiple responses and we average it out. Again, that's another measure that'll come into play a little bit later when we talk about treatments. So those are all continuous measurement procedures. For discontinuous measurement procedures or interval recording or time sampling, there are three approaches. Whole interval recording, where the response is going to be scored if it occurs throughout the entire interval. Partial interval recording, where the response is scored if it occurs during any portion of the interval. Momentary time sampling, the response is scored if it occurs at the end of the interval. So keep in mind that these data are always calculated as a percentage of intervals or trials in which the target was observed. And each of them are going to be more or less sensitive to specific targets that you're looking at. It certainly will depend on your interval time, and we'll talk about that when we discuss the Fisk article. But the big benefit here is that these are often thought of as less labor-intensive data collection methods. So for example, if we take partial interval recording, it could simply be yes, no. Did the behavior occur? We don't care the count, how much it occurred. We just want to know, did it or did it not occur in this interval time period? So we want to select the measure that's going to best capture and represent the target behavior. The example I always give here is considering something like out-of-seat behavior. A count's not particularly sensitive because if the child only gets out of his or her seat twice, that seems rather low. But if each time they're out of their seat, they're walking around for 5 minutes, duration is probably the more sensitive measure. So you need to think about that. And there's no hard, fast rules I could provide to you to say, well, with this behavior, you're going to measure it this way. With this behavior, you're going to measure it that way. It depends on the individual client you're working with. The other thing I mentioned is we need to balance gathering accurate data with the labor involved in gathering those data. And again, the Fisk article addresses this. Continuous data collection is difficult, right? We need to, if we're utilizing a count, that means we need to observe the client the entire observation period. So if I have a 10-minute session, that means I cannot take my eyes off the client for that entire 10 minutes, and I have to record each instance of behavior. That is, for the average person, that's hard to do. When you're involved in the type of work that we do, that's you're trained to do that. That's part of what we do. Again, consider if you request for a teacher to record the duration of out-of-seat behavior. If that teacher has 10 other students in the class and she has to observe and record Johnny each time he gets out of his seat, that's a lot of labor involved. So you may get sort of compliance to the teacher doing that, but the accuracy of the data may be problematic because it's so hard to do. So therefore, we often will select one of these discontinuous procedures because it allows us to get decent data and there's not a lot of labor involved. However, they have errors because they are estimates of behavior. So again, consider this partial interval recording. If I want to know how many times or how often Johnny's getting out of his seat, rather than have the teacher record duration across the entire instructional period, which might be a couple hours, I'll just use partial interval recording and I'll divide the day or the teaching session into 10-minute intervals. And all I want the teacher to do is circle yes or no, was Johnny out of his seat during the 10 minutes? So again, the problem with that is he may have only been out of his seat for 1 minute, but it occurred, so it's still getting scored as yes. Okay, so we have an estimation error there. All right, what I'm going to do is look at some examples. The first two examples are examples that I selected, and then I selected some examples from the assignments that you submitted. So you may see your assignment here. Okay, so this comes out of an article published in 2011 by Jeanette and Hagopian, and it was the evaluation of response blocking and representation and competing stimulus assessment. You don't really need to know what that means, but trained observers recorded the frequency of SIB, which was defined as successes or attempts at head hitting with open hand, closed hand, or object, biting fingers or hand, and head banging. So you have a variety of different behaviors in a response class definition of SIB. Again, obviously we need to know what each of these looks like, and that's not often reported in the research because it's individualized. Then they mentioned the frequency of data for SIB were converted to a rate, responses per minute, by dividing the total number of responses scored during each session by the session length in minutes. So for example, what this may look like is you have a 5-minute session. During that 5 minutes, you counted 50 instances of SIB. You divide it by the 5 minutes, it's 10 responses per minute, or 10 SIBs per minute. And that would be plotted on the graph for that observation. Then we would do it again and record how many SIBs are occurring. So this is sort of an example of a target behavior with a response class definition and then a measurement procedure. Okay, here's another one. Utilizing latency. So follow this one carefully. This is latency of response during functional analysis of elopement. Elopement means running away. So session or a trial duration was 5 minutes or until elopement occurred, whichever happened first. Elopement was defined as any part of the student's body passing through either of 2 classroom doorways, except during the attention condition in which elopement was prevented. That's sort of a separate issue. Observers recorded the amount of time in seconds that elapsed from the start of a session to the first instance of elopement. So that is your latency. Session begins, the timer starts. If elopement is observed, the timer is stopped. Right, so session observation period was 5 minutes. Occasionally we'll convert this to seconds, so 300 seconds. Session begins, timer starts running. The first instance of elopement stops the timer, right? So let's just say it occurred at 1 minute or 60 seconds. So we'd plot that 60 seconds out of 300 seconds. If no response were to occur during the entire session, you would plot 300 seconds. Now, this is probably difficult to comprehend if you're not observing the graph. You will see one of these at some point. If you're interested, look up the article and you could get a better idea of what's happening here. But just another example of a target behavior with latency. So here are some examples I took from a couple assignments. This one came from Lynn Bowman article in 2013, a functional analysis of crying. So let's look at the target behavior definition. Crying was defined as 3 seconds or more of moaning inarticulate sounds above conversational volume, with or without the presence of tears or rapid breathing, short, quick, audible breaths. I thought that was a nice restriction there, with or without the presence of tears. Having a 6-year-old, there's some fake crying that goes on. So that's your definition. And they say trained observers sat behind a one-way window, use laptop computers to record the total duration of crying, which was defined. I'm not going to repeat the definition again. But then they say the percentage duration of crying was calculated by dividing the duration of crying by the duration of the session and converting it into a percentage. So I have an example down here. We have a 10-minute session. Time is going from left to right in this sort of illustration. And let's just say the session begins, nothing happens, and then about a minute in, we get 3 minutes of crying. So the data collectors using laptops started a timer, perhaps on the laptop, and let's just say crying went on for 3 minutes, it stopped, then they stopped the timer. A little bit later, crying begins again. They start the timer. At the end of it, they stop the timer. Then again, crying begins. They start the timer and stop the timer. So out of this one session, this 10-minute session, there was a total duration of crying that equaled 8 minutes. So if we divide the 8 minutes by the 10-minute session, multiply by 100 to convert it to a percentage, we get 80% of the session the participant was crying, right? So we have those data. Now, interestingly enough, when you do something like this, we also have the count of crying, if you, or the episodes of crying, we'll say, right? So here's one episode, 2 episodes, 3. So there are 3 episodes of varying durations within our 10-minute session. But again, it highlights that for this behavior, crying is probably a more sensitive measure than counting individual episodes without reporting the duration. Okay, here's another example. The effects of variable time delivery of food items and praise on problem behavior reinforced by escape. So there are a variety of operational definitions in this one. I only highlight 2 of them, but aggression defined as hitting, punching, slapping, and pinching, scratching, pulling hair, biting, throwing objects at the therapist. I think I worked with that guy. Destructive behavior defined as throwing objects at people, knocking over furniture, materials, or objects, tearing materials. And then there's another definition for another participant for yelling behavior, which I thought was interesting. So yelling defined as any word or non-word vocalization above conversational level that lasts less than 3 seconds. Now, just to sort of hone in on this definition, it's a decent definition. But again, when you talk about things like qualifiers like above conversational level, it does get a little subjective. If my hearing is not so good, which at my age it's not perfect, from too many loud concerts, it's very subjective. What's above conversational level to me might not be above conversational level to you. So they say the target responses were converted to a rate measure by dividing the number of responses in the session by the number of minutes in a session. So again, looking at my illustration here, 10-minute session going across the bottom of the screen, we're observing and we record 12 aggressions, right? So let's just say we're using pen and paper data collection. We have a timer set for 10 minutes. We start observing. I jot down 12 tally marks for under aggression. Then I have another section for destructive behaviors, and I make 2 tally marks because there were 2. At this time period, I count 3 aggressions and 1 destructive behavior. Then I count 3 aggressions. So looking at those targets separately, I have a total of 18 aggressions. So 18 divided by 10, that's 1.8 aggressions per minute that I'm going to plot on a graph. Destructive behaviors were 3. So 3 divided by 10, 0.3 destructive behaviors per minute. So I have these 2 pieces of data that I could plot on a graph individually. I could also do what's called combining them into combined problem behavior and simply say, I could simply add these if I wanted to and divide by 10. Okay, another example here, compliance. The initiation or completion of teacher-stated instruction within 15 seconds of the instruction. The observers used a data sheet partitioned into 30-second intervals to record data on teacher-child interactions. So again, I kind of made up this example here. Let's just say we did a 30-minute observation and we have our data sheet here, and I simply observe and I see the teacher delivers an instruction. So I put a check mark that it occurred in the interval, 30-second interval. Then the student complied. In another interval, the student provided an instruction, student complied. Teacher provided another instruction, and the student complied. In this interval, the teacher provided an instruction, the student did not comply. In this interval, the teacher provided 2 instructions, the student complied to one, but not the other. And then we wrap up with 1 instruction and then compliance. So all I do here to convert it to the percentage is I need to look at how many times the instruction occurred, and there were 7 of them, and how many times the student complied. So 5 divided by 7 times 100% is 71% compliance during this observational period. Now I could also calculate non-compliance here if I want it, because I have those data. So another thing that I think is worth pointing out here is the example that I was providing a while back with respect to observations, that we have, in order to determine the percentage of compliance, we have to know how many opportunities there were for the student to comply, right? So therefore, we need to collect data on the teacher's instruction in this example. So that's important to consider, that if we're looking at a target like compliance, we can't just, without reference to an instruction, measure compliance. We have to reference how many opportunities there were to be compliant. So in this case, we call this a free operant observation, where we're not contriving how many opportunities there are. We're just observing how many times the teacher provides the instruction. However, in an analog condition, I could contrive how many instructions are provided. I can ensure that there's 1 instruction provided every interval. And there might be a benefit to doing that in terms of providing intervention, right? I need to have multiple opportunities to maybe reinforce compliance or intervene. So something to think about. In this example, I just used checks, but we could also develop a data sheet that reflects yes or no, or pluses and minuses. You'll see a variety of these later in the semester when we discuss creating or designing data sheets. Okay, here's another example. I think it's the last one. The use of auditory feedback and edible reinforcements decrease toe walking among children with autism. And they define toe walking as one's heel does not touch the ground when taking a step. And they say the target behavior was a percentage of steps in which the participant engaged in toe walking. So now that's important to highlight, that they have a behavior called toe walking, but the actual dependent variable, the thing that's being reported or changed, is the percentage of steps in which toe walking occurred, right? So they say data was, it should be data were, collected by videotaping each participant, and then the observers watched those videos and recorded the number of steps with toe walking. So if you think about how to actually do that, let's just say, for example, we have a 1-hour observation, and in order to calculate this, we need to know how many actual steps occurred, and of those actual steps, how many included toe walking. So I have regular steps sort of reflected above. Let's just say the participant took 10 steps, but 2 of them had toe walking. So I need to record each step, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I also have to record how many of them had toe walking. Here we have 30 steps, 12 of which had toe walking. Here we have 13 steps, no toe walking. So total steps equals 53. Total steps with toe walking is 14. So 14 divided by 53. 26% of the steps had toe walking. Okay, so hopefully that provided a sort of a sample of um, target behaviors as well as data collection procedures and what we're actually doing when we say we're measuring these behaviors. So I want you to keep in mind that this is a large part of what we do. It's not just developing strategies to change people's behavior. We have to measure the changes, and the only way to do that is to have a accurately described target behavior, accurately defined target behavior, observe it in a variety of contexts, and measure it using a measurement procedure that will be sensitive to the given target behavior. So that brings us to the Fisk and Del Molino article, 2012, Use of Discontinuous Methods of Data Collection in Behavioral Intervention Guideline for Practitioners. So we've obviously covered all of this material last week, and then we just reviewed some of it this week. So this article came out of Behavior Analysis and Practice, which is a nice journal for practicing behavior analysts because it's not always exclusively research focused. It's sort of how does the research really impact or inform practice? So you'll get articles like this where these authors are providing guidelines based on the research that's been done, guidelines for practice. So we're going to go over this briefly. I'm not covering all the areas, but hopefully you found all the areas helpful in clarifying what we've already reviewed. So they talk about continuous measurement and discontinuous measurement, and they note the strengths and weaknesses of these measurement procedures. So in continuous measurement, the strength is that we're getting a comprehensive account of performances, of behavior. And hopefully it's probably the most accurate approach because we're not estimating, we're actually capturing all of the data, all of the behavior that's occurring. The weakness of this approach is it's very labor intensive. The person collecting the data has to observe the entire time. Some folks even indicate that in some cases, particularly when you're providing instructions or skill acquisition work, when we're addressing skill deficits, the act of collecting data could be disruptive to learning. We'll talk more about this in a class, ABA 514 and Interventions for Autism. But within that type of work, there's what's called discrete trial instruction or discrete trial teaching or training, DTT. And it's characterized by very structured trials where the instructor provides what we call an SD. They might provide some prompting. They wait for the child to respond. And then maybe we provide reinforcement or error correction, and there's an intertrial interval. And we collect data. Some research has shown that collecting data breaks up the flow of the instructions. So if I run through those steps, providing instructions, wait for the response, and then I turn away to collect data, that could be enough for some learners to become disrupted, as opposed to just simply running through the instructions without any data collection. Obviously, there's a problem there as we can't evaluate the intervention. So that's one weakness or limitation of continuous measurement. It's not too significant. It's only really in one particular context that it might be a problem. Discontinuous measurement, again, we're only recording a subset of data, so think of it as a sample. It is less labor intensive, and that is the strength. The weakness is it introduces an error. If you consider partial interval recording, it overestimates how much behavior is occurring. Whole interval recording underestimates how much behavior is occurring. But as long as these errors are consistent, it's not too problematic. We're only estimating behavior. The other thing is it may provide an inadequate sample, right? We may not know when an individual has reached mastery on a given skill if we're only using estimates of behavior. So they also talk about determining observation times and interval durations. And again, they're sort of guidelines for doing this. The observations obviously need to be long enough to detect the target behavior. And they recommend, based on some of the literature they reviewed, that longer observation periods are better for detecting low rate behavior. Now, I think I gave an example of this earlier. If a target behavior occurs based on parent report once every hour, if we only set up 10-minute observations and we do 3 of them, that's for 30 minutes, we may not see the target behavior. So we may want to go with longer observation periods. Shorter observations are better for detecting moderate to high rate behavior. So if the behavior occurs on average once every minute, in a 10-minute session, we're going to get an adequate sample. So that would be sort of the loose guidelines for figuring out how long your observations need to be. Will you be able to detect the target behavior? If we're using discontinuous recording methods, the interval duration needs to ensure sensitivity to the measurement. And the basic rule there is shorter duration of an interval introduces less error, but it's more labor intensive. So for example, if I have this 10-minute observation period and I divide it into 5-second intervals, that would be very difficult to collect data, particularly using pen and paper. So imagine yourself and a timer is going off every 5 seconds and you're sort of going interval by interval inputting data. With a computer, the intervals are sort of timed in the background. All we need to do is record behavior when it's occurring, so not too problematic. But short duration would be 5 seconds, 10 seconds, something like that. Longer duration intervals introduce more error, but less labor, right? So there we're talking 30-second intervals, 1-minute intervals, even 30-minute intervals. So these are the considerations when we're designing these things. So if I'm recording data using software on a computer, I could set the intervals for 5 seconds. And I don't need to track, am I in interval 1, 2, 3, 4, 5? I just simply record data as I'm seeing it, and the computer assigns the data to each interval in which it was observed. If I'm using pen and paper data collection, I would probably never collect data using 10-second intervals. Again, it would just be mind-numbingly difficult to do that. So longer duration is better there. And they set up a figure that I thought is nice for delineating which type of procedure is going to be suited for the behavior you're addressing. So it's sort of a decision tree where they're saying at what level and in what direction will the behavior change? Are you going from low to high? You're trying to teach a skill, addressing a behavioral deficit, or are you going from high to low where you're trying to decrease a behavior? So in low to high, behavior increase, they're saying if the behavior needs to increase to 100%, right? Maybe you have a goal of the behavior being 80% or above, or 90% above, or 100%. Whole interval may be better. If it doesn't really matter, momentary time sampling may be fine. And they say that they have a cautionary note here that small changes in very low levels of behavior may not be detected initially using these procedures. So you'd have to be careful of that. In the other direction, high to low, here is where we're trying to decrease problematic behavior. If the behavior needs to be near zero, partial interval recording may be fine. If not, if you just need to decrease it maybe to 10%, momentary time sampling may be fine. Okay, and they have, again, some cautionary notes. I'm not going to review those. So although there are no standard rules that we'd follow for selecting whole interval recording or momentary time sampling, there are some general considerations, and that's what this article is laying out for you. So I think some of the recommendations I would highlight is to use discontinuous sampling where there are multiple demands on data collectors, right? So if it's a parent or a teacher who you're asking to collect data, you're probably going to move to discontinuous data collection methodologies. You also want to consider the targeted behavior change. What direction are you trying to change a behavior? Are you trying to increase behavior or decrease behavior? And that may guide you to select whole interval recording or partial interval recording or momentary time sampling. Okay, so hopefully that provided some additional guidelines for how we're utilizing discontinuous sampling methods. The next article that I assigned was by Tara Fahmy and Greg Hanley, Progressing Toward Data Intimacy, a Review of Within-Session Data Analysis. Now, I always assign this article, but upon reading it again, I think there's useful information here. It may be a little bit challenging for you to really fully grasp at this time because we haven't covered enough content, but we'll come back to this article again and hopefully make a little more sense of it. But in the introduction, they highlight how in the experimental analysis of behavior, quite frequently researchers will utilize a cumulative record. And I believe all of you are in or have had ABA 503, so you are familiar, or you should be familiar with a cumulative record, what it does. So it's basically a device that just measures behavior as it occurs. And each response is recorded. So there's a little pen, and each time the pigeon or the rat or human responds, the pen moves up, right? So you typically get these response curves going in a single direction, right? And then the pen resets, and then the curve begins again. So there's a little example here, and you just have this ongoing record of responding occurring. And the utility is you could detect these moment-to-moment changes in behavior. Now recall, it's cumulative, so each response is added to the previous response. So you're only going to see a curve in an upward direction if responding is occurring. If responding stops, the curve doesn't go down, it just flattens, right? So when there's no kind of the data you're seeing on COVID is cumulative in a sense, so you can see the curve flatten. And they indicate that in applied behavior analysis, there's more of a focus on the summary of responses. You don't really see applied researchers or practitioners using cumulative responses. So essentially here we set a session time, we observe and record responses, and we summarize them, maybe as a rate or percentage of intervals, and we graph them, right? So the data that we're visually analyzing looks quite different than the cumulative record because you have high-level responses, low-level responses. So it's not a curve per se, it's just sort of the level of behavior that's being emitted during an observation, not moment to moment. We have those data, so don't mistake that, but we're summarizing the observation. But we have this option to look at the data cumulatively, and that could provide a more thorough analysis. So we're going to go through some examples of what that looks like. So again, with applied work, we often aggregate the data. We have an observation, we recorded many responses. We could consider those responses in a cumulative fashion, but we don't often do that. We simply aggregate them. We provide a summary for one data point, right? So the percentage of responses, maybe there were 5 responses that occurred during 10 intervals, so we report 50%. But it doesn't show you when each response occurred. Within session responding is when the individual's responses are recorded in the observation. We could plot these minute to minute. So within one observation, rather than summarizing the 5 responses, we could plot each one of them and on the graph and look at the responding minute to minute or even second to second, depending on the technology you're using, or we could plot them cumulatively, and it might reveal some things. So I want to go through some examples here to highlight this. I guess before getting into that, Fahmy and Hanley sort of present this idea that once you have data gathered, you could analyze it according to a continuum, right? So if I have an observation that I've conducted and I've captured the count of behavior within that observation, I could, over many observations under many conditions, I could analyze those data in a variety of ways. Typically, we would analyze them according to session, right? But I can look at each one of those individual sessions and observe the within session responding, right? So for session 1, what did responding look like within that session? Not as a summary, but each individual response. Moving from session, we obviously analyze data according to experimental phase or experimental condition and so forth. So we could move from sort of distant analysis or get very intimate with the data and gather more information. So they go on to present some examples, but before getting into those examples, I want to consider how analyzing data in different ways or cumulatively might reveal the effects of motivating operations. So we're sort of drawing in content, or you have to have knowledge of motivating operations. And I think those in 510 probably are aware of motivating operations at this point. But if you're not, essentially a motivating operation is a condition, environmental condition, that changes the value of a reinforcer, and as such, it will alter the frequency or level of responding that's maintained by that reinforcer. So let's consider two possibilities or two illustrations of how cumulative responding might reveal the influence of a motivating operation. So let's look at the first one, longer exposure to a session condition. And I have a later example of this in the PowerPoint. So stronger versus weaker MO. So let's just say we're looking at behavior in a condition where the child's behavior is maintained by by attention, and each time they engage in the target behavior, we provide attention. Well, if we're looking at session duration in this first graph here, let's, I think I should change my pen color. Let's consider that in minute 1, the MO, or more specifically, the establishing operation, is not very strong, right? The child just entered the session. Maybe they just came out of a period of receiving attention. But as time goes on, the EO is going to strengthen because there's no attention being provided. So then you're going to see an increase in responding. So if we consider session duration as an MO, right? The longer you go without attention, the stronger attention becomes. The maximum effect of the EO is probably going to be midway in the session in this example, right? So that sort of gives us a little insight into how long does an observation need to be. If we only did a 2-minute observation, we're not going to get a lot of useful information. If we do 5 minutes or 10 minutes, it's going to produce a better picture. Right, here, this example is even a little bit better, right? So minute 1, the EO is not very strong, but as time goes on, the EO strengthens, and then we get a lot of responding. So that's one consideration. Let's consider another one. We'll use this example here. So again, remember, these are cumulative responses. So if we're using edible reinforcement, or any reinforcement for that matter, but edible, I think, is a clear example. Often before we start teaching, we would deprive the individual of that edible reinforcer. So if you're using M&Ms, the child should not have access to M&Ms. So therefore, the motivation is strong. The child's going to engage in a lot of responding to gain access to the M&Ms. However, after they've consumed so many M&Ms, they're going to become satiated. Therefore, those reinforcers will lose their value and responding will cease or decrease. So therefore, we get responding occurring when motivation is high. When motivation decreases, responding stops. So we flatline there. Okay, so these are sort of illustrations of how, if we're looking at the cumulative number of responses within an observation, we can see the effects of motivating operations quite clearly. All right, so let's look at some other examples from the literature on how within session responding helps in sort of clarifying an analysis or just providing us with a better picture of what's happening. So these are data from a study conducted by Northup et al. In 91. It was a particular type of brief functional analysis. We talked about it in ABA 510. So here are the data, summarized data for each session. So session 5 here, you have aggression in the dark circle and using a sign language in an open circle. So when we look at these data, we have a summary of a single data point. However, if we took session 5 and analyzed responding in a minute-to-minute fashion, it would look something like this over here. So this contingency reversal 1 condition is this one here, right? This summary data point is made up of all of these summary data points. So look at this, that you have 0 responding for the first 5 minutes of the session. Then you start to see responding occur, right? So you have 1, then another one, so forth. So we get a slight curve. When you look at sign language occurring, this is a treatment condition. Early on, it starts immediately increasing. Right, so these two representations present different pictures, right? We see problem behavior occurring, but it didn't really occur until the second half of the observation. So just something to consider there. Here, not much to really depict, right? There's no problem behavior occurring in that alone condition. Then when you get to the second contingency reversal, similar pattern. There is some level of problem behavior occurring, but again, you don't start to see more of it until later in the session. Okay, so again, just another example of often we simply summarize the data as a single data point, but if we have the data minute to minute, we could plot it and it might reveal useful information. Okay, here's another example. These data are not being plotted cumulatively, but this is an example, again, from an article we read in ABA 510, where we're looking at minute-to-minute responding in a single observation from a functional analysis. So you have minute-to-minute responding going across the bottom, and you see responding for this individual in a tangible condition. Here's a negative reinforcement condition. Now, again, interestingly, you see a lot of responding in the beginning of the condition, but then it zeroes out near the end. So that's kind of interesting information. Not only that, when they repeat that session, you see a similar pattern. So one would have to question, is this condition truly evoking problem behavior, or is it just in the beginning of the condition, you see it, but then it goes away once the condition continues? Okay, you see similar example down here. Just again, where responding starts to occur within the session across time. Okay, here's an interesting article where Michelle Wallace and Brian Iwata compared responses in an FA during 5, 10 to 15 minutes. Now, this isn't particularly relevant to this course, but the examples are relevant to what we're talking about. But it's an interesting research paper because it's empirically showing us, well, how long does an observation need to be? What is the best observation time, right? Or could we conduct a 5-minute session and still get useful results? Or does the observation need to be 10 minutes or 15? So looking at these data, I'm going to focus, I think, more on Rodney's data down here. These are sessions, a demand session, so particular condition, experimental condition, at 5 minutes, and they're looking at responding at 5 minutes, 10 minutes, and 15 minutes. And they're just pulling out individual sessions. So the first session, the second, third, fourth, fifth, and sixth, and so forth. So you see an interesting pattern of responding here. And it's probably hard to detect in this set. But if you're looking at the first FA demand session, responding is 0 for 5 minutes. It's also at 0 for 10 minutes. It's not until 15 minutes in do you start to get responding. So now imagine if, as a practitioner, I elected to do 5-minute sessions. They're not sufficient enough. The duration is not long enough to capture responding. So let's look at the second demand condition, which is the closed circles. So again, no responding for the first 5 minutes. After 5 minutes, you start to see responding. Okay, so again, 5 minutes would not be long enough. We'll jump down here to the sixth session. Now you do see responding early on, but most of it is occurring after 5 minutes. So I think a couple points with this data set, and again, it's sort of high level stuff that may make a little more sense after you've had ABA 510. At 5 minutes, it does not seem to be sensitive enough to capture responding. So therefore, 10-minute sessions are better. 15-minute sessions, probably useful, but obviously take longer. So I would probably target 10 minutes. The other thing that's revealed from these data is the more you expose the individual to the session, again, this is a demand condition, first exposure, second, third, fourth, fifth. By the sixth exposure, the person is responding within the 5 minutes. So kind of interesting example there. Okay, that is it. It was a lot, particularly at the end there. I think it was, like I said, pretty high level stuff. But the idea behind the second week of measurement is to give you an opportunity to further review some of the content that we discussed last week. And then I added some new clarifications in there or new things to think about, new considerations that I want you to integrate into what you already know. And then we just touched on some articles, particularly I think the Fiskin-Dumoulin article should have further clarified why we would elect to use discontinuous sampling procedures. The Fahmy and Hanley article, difficult to comprehend, but what I want you to really take out of that article is once we have data collected, we typically summarize it, but if that summary is not revealing a useful picture to us, we can dig a little deeper into the data. That I think is what we should be getting out of that article at this point. Okay, so again, this week is a completely online. There will be no virtual session. If you have questions, however, feel free to send me an email. I will post a quiz, and that's it. Have a good week.